Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq bin Muhammad Noor, and today I'm going to demonstrate how we simulate our circuit from project assignment, as shown in display in the screen. So we have two type of source and a capacitor impedance. Industrial load consists of R and JX and inductive impedance. So these are the detail because we are from group 5. These are the detail that are given for us, which is source 1 with 240 and angle 0, source 2 with 40 and 25, 40 magnitude and 25 angle, while the capacitor impedance is 35 ohm and inductive impedance is 30 ohm real and 30 ohm imaginary J, and industrial load is 15 ohm real and J10 ohm for imaginary. So inside PSpice, we are going to simulate like this. First, we need to find the part which is for the source. We just click over here and we implement the sinusoidal for source 1 and source number 2. After that, we input the component which is the capacitor. Firstly, we input the capacitor over here and a resistor over here, which is for the industrial load, and impedance load over here. And lastly, we input the inductor over here. And one is over here. Oops. Sorry. Okay. And after that, don't forget to put ground because we are simulating in PSpice. If you don't put ground, the simulation cannot run. So we need to put ground over here. And next step is we label the component. So for the V sinusoidal component, oh, sorry. For V sinusoidal component, we drag it a bit so that we can see what component do we label. So for V off, we just put 0, and AC voltage also 0 because we are in transient. I mean time domain analysis, we does not need to put the V off and AC for inside PSpice because we are doing transient analysis. That's why we need to implement like this. And for, oops, I need to label back over here 0, and V amplitude is our magnitude voltage for source number 1. So as given just now is 240 angle 0, right? So you write like this. And okay, while the frequency we set up to Malaysian standard, which is 50 Hertz. So just click OK. And just imply the same method as we do for source number 1 over here, and 0, while the magnitude for source number 2 is given by 40. 40, angle is 25. Okay, angle is 25. Frequency also set using Malaysian standard, which is 50 Hertz. Okay, now we label the capacitor, but we do not input the value for imaginary. We just convert into component value. So the value for component capacitor is 90.95 microfarad over here. My friend will explain over the next session how do we convert imaginary value to component value. So same for the other part. For impedance, 0.0955. Okay. This is for inductive impedance, and this is for industrial impedance. We convert 0.0318. Now we wire. To wire inside PSpice is just easy. You just uh wait. need to arrange so that it will become neat. Just click W over your keyboard and wire up the components over here. So you wire up one by one until it become complete circuit. So you wire up, and finally to the respective to the ground over here. Okay. Okay. This is wire up for industrial load, consists of resistor load and inductive load. And finally, we wire up ground. Okay, so now our circuit inside PSpice is complete. So this is the circuit for simulation. Now, if you want to simulate using because the project assignment asks us to simulate in time domain, so we are going to use transient analysis type of simulation. Inside PSpice, there are two types, which is steady state and transient. So we use transient because we input both of the voltage. Oops. Wait, sorry. Okay, because in PSpice we use transient steady state because this is both V sinusoidal source, so we just input inside PSpice using transient analysis steady state. So just we set up the time delay into 0.1 and maximum step size to nanosecond or so that the probe can read to millisecond over there. So just you click over here time domain and set up the time as show and click apply, and then you click OK. So let's say that we want the voltage at the industrial load. So you can choose which probe you want. You can have voltage, you can have potential difference also. And this is the current, and this is the power. So let's say we want voltage at here. So you put at here both. So and then you click over here, run PSpice. So after you run PSpice, the probe will become green and you can observe the output over here. So this is the value for, oh, sorry. This is the value for voltage, potential difference at industrial load. So this is how you see the voltage. To find the peak, you find the peak over here and you can label it. So that is how we implement the circuit inside PSpice simulation. So that's it from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shazwan bin Aslan. My meter number is CE220037. So today I will present about the Z-load voltage and also Z-load current. Okay, as we can see, this is a constructor circuit that been done. And this we have power source, the capacitor, inductor, and also resistor. Okay, and then we move through to the graph. And this I will explain about the graph, the condition of the graph, the value of the V peak. Okay, as we can see, V peak of this graph is 97.901, and also at the time delay, which is 38.58 millisecond. Yeah, and then we go through the plot graph of the Z current. Okay, it's just the same circuit as above. Okay, and then we go as you can see that this is a different waveform than the voltage one. You see this is a huge gap between the V peak. Okay, and for V peak current, we can see here that is 4.8445 and with the time delay of 20 millisecond. Okay, that's all for me. Thank you.
Assalamualaikum, my name is M.Rifqi and my metric number is DE200115. So, for this part, I will show the simulation of capacitor voltage, which is to measure the capacitor for the circuit. Firstly, we need to use a probe, which is we will parallel with the capacitor to measure the voltage. And then when we run it by using a multisim software, it will produce the result, which is the peak value for the voltage at the capacitor is about 273.063 voltage with a delay second is about 26.534 milliseconds. And then to measure the current, as look like the figure, uh, we will put the uh, multimeter or ammeter in series with the capacitor to find the value of current at capacitor, and then it will produce the graph, which is the peak value for the capacitor is about 7.9125 amp with a delay second 20.622 millisecond. That's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iman Aiman bin Muhammad Din. My matrix number is DE200077, and today I will present about the simulation for uh, assignment project to find the inductor current and voltage of the from the simulation. So the simulation is done using PSpice, and to find the inductor voltage, uh, we have put a voltage probe on the inductor side of on the inductor, and then after we run it, the probe will show the waveform of the voltage. So from the waveform of the voltage, we get the voltage in the inductor voltage, which is 88.756 volt on the time delay of 15.078 millisecond. And next, to find the inductor current, we've put one current probe on the inductor, and after we run it, the waveform of the current was shown, and we've got the inductor current value, which is 2.6099 ampere on a time delay of 20.492 millisecond. And that's all, and that's how to simulate and find the inductor current and voltage using PSpice. That's all for me. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rashid Ramli. So, I will explain about the circuits and compare the manual calculation with software calculation. So, to get the value of C1, capacitor 1 is in the simulation, the value is 90.95 microfarad. Then for the manual calculation, use the formula HC 1 over 2 pi FC. So put the value to frequency is 50 and HC is 35. So calculate using calculator, then get the same value to the circuit software. Then how to get the L2 in software? The value is 0.05955. So manual calculation using formula XL equal to WL. So W is 2 pi F. Then put the value. Frequency is 50. Then L is 30. So get the value 0.0955 Henry. So how to get the value of value of L1. So the value of L1 in software 0.0318. So put the formula in manual calculation SL. Same with L2 also, and L1 is 10. Then put in the formula, then get the answer 0.0318 Henry. So this is a comparison with manual calculation and software calculation. Thank you very much. That's all from me.